Hi, Block 4. I'm sorry I'm not able to be with you today, but I would like to continue our look at section A.3. We are looking at factoring right now in A.3, and factoring is an important tool for solving equations and simplifying rational expressions. And it's important to note that if a polynomial cannot be factored with integer coefficients, then it is prime or irreducible over the integers. So let's just start looking at a few examples. So if we have x squared minus 9, that can be factored, as you know from Algebra 1, that can be factored into x minus 3 and times x plus 3. Right? That's a difference of two perfect squares. X squared minus 3 can be factored also, but only if you step outside of the integers. So for example, it can be factored into x minus square root of 3 times x plus square root of 3. But we won't really consider that factoring. All right, it can be factored over the real numbers, but not over the integers. So for us, it doesn't count as factoring. All right, so we would say this one here cannot be factored. All right. Okay, a polynomial is completely factored when each of its factors is said to be prime. Let's take a look at an example of factoring when you have 4 terms to factor. All right. So let me slide this up a little bit here. All right, so if we are factoring this, we can factor this by grouping. So let's group these first two together. What can we factor out of those first two? Well, we can factor out x squared, and then what would be left in the parentheses for these first two? X squared times what gives us x cubed? That would be x. X squared times what gives us a negative x squared? That would be a minus 1. Sorry if my writing is kind of sloppy. And what about this next grouping? What could we factor out of the 4x minus 4? Well, we could factor out a positive 4. So I'm going to write plus 4. And then in parentheses, we would have what? 4 times what gives us the 4x? That would be x. And 4 times what gives us a negative 4? That would be a minus 1. Well, do we have the same thing in parentheses here and here? Well, we do, and because we have the same thing, that means we can factor that out in front. So we would write this as x minus 1, and what's left is going to be this and this. So that goes in its own parentheses, so times x squared plus 4. All right, so that's how we go about factoring if we have a difference of, if we have 4 terms. Let's try one more example like that. Let's try this example here, which looks very similar, except some of the minuses and the pluses are in different places than they were over here. All right, so let's try this one out using the same factoring by grouping technique. So if we group these first two together, we say, what can we factor out of those two? To me, it looks like we can factor out an x squared, and what's going to be left is x minus 1. And then what can we factor out of these next two? Well, this time I think we would want to factor out a negative 4, so that we would still end up with x minus 1. Negative 4 times x is negative 4x. Negative 4 times negative 1 is a positive 4. Do we have the same thing in parentheses? We do. So our answer here in factored form would be x minus 1 times x squared minus 4. But it's not our final answer, because x squared minus 4 can be factored further. So this is not a prime factor. So we need to factor them all down to primes. So we get x minus 1 times x minus 2 times x plus 2. Now that is factored completely. So this is our final answer for this problem. All right, let's take a look at some other ideas regarding factoring. And first of all, a big tip here, always start by looking for common factors. So let's make sure that we can do that. If we were going to factor out 8, if we were going to factor 8x to the fifth minus 6x squared, we would say, what can we factor out of both of those terms? And that would be a 2x squared. So what's left? 2x squared times what gives us this 8x to the fifth? It would have to be 4x to the third. And 2x squared times what gives us negative 6x squared? That would be a minus 3. Just a minus 3. So that would be our final answer there. We had a common factor that we could factor out. All right, let's skip that one for right now. Let's go to this one. We've got x plus 5 times 3x plus x plus 5 times 6. And if we're going to factor this out, please notice that this is one term here, and this is one term here. And so we're going to say, is there anything common to these two terms? Anything that they share? Well, they both have an x plus 5, so we can factor that out in front. And if we factor that out, what's left but the 3x and the 6? So we have 3x plus 6. And now that is factored. All right, they do have special factoring forms, and they are listed on page A27. So let's take a look at some of those. The first one is the difference of two squares, which we've already used a couple times in this lesson. So u squared minus v squared factors into u plus v times u minus v. By the way, kind of glossing over this, but when we factor something, that means we're writing it as a product of two or more things. So u squared minus v squared is a difference of two things, but when we write it this way, then it is a product of two things. All right, we have more special factoring forms. The next one the next set is the perfect square trinomials. U squared plus 2uv plus v squared. If you have three things added together and they fit that form, it can be factored into u plus v quantity squared. That is a binomial squared. Same thing if you have u squared minus 2uv plus v squared. That can be factored into u minus v quantity squared. And the last set of these these special factoring forms is the sum or difference of two cubes. So the first one looks like this: u cubed plus v cubed can be factored into u plus v times u squared minus uv plus v squared. And there's one for the difference of two cubes also. That's interesting. A little typo there, which you guys have probably been staring at. Let me fix that because it's going to bother me. All right. Sum or difference of two cubes. And so the second one was u cubed minus v cubed factors into u minus v times u squared plus uv plus v squared. So let's take a look at a few examples of using these special factoring patterns. First one is 25x squared minus 1. First thing you notice, there are no common factors between these two terms, but it can be factored by using difference of two perfect squares. So what do we need to square in order to get 25x squared? Well, we would need to write it as 5x quantity squared. And what would I need to factor in order to get 1? That's supposed to be squared. Oh, interesting. Let's get rid of that. So what would we need to factor here? There we go. We would need to factor, we would need to write 1 squared. So this is going to factor into 5x plus 1 times 5x minus 1. All right, and that brings us to another example. How about this one? If we are factoring 4x squared plus 12x plus 9, first of all, this might fit the perfect square trinomial type, and if it to find out whether it will or not, you're going to look at this. Two questions. First of all, is that a perfect square and is that a perfect square? That was one question. The answer is yes. And the second question is, does this fit a pattern of 2uv, where this is u squared and this is v squared? So first of all, let's figure out what is u and what would be v for this. So for this one, we have to say, what would we need to square in order to get 4x squared? And the answer to that is 2x. And then second, what would we need to square in order to get 9? And the answer to that is 3. All right. And then that means that the 2x is the u and 3 is v. And so we're wondering, does this fit the pattern of 2uv? That would be 2 times 2x times 3. Does that fit that pattern? Sure, because that would be 4x times 3 is 12x. That means this does fit the pattern for a perfect square trinomial. And what is that perfect square trinomial? Well, it's just going to be the u plus the v quantity squared. So it's going to be 2x plus 3 quantity squared. So that's how we would factor something like that. And let's take a look at another example from the special factoring patterns, and this one is 27x cubed plus 64. Again, I would ask you to consider, what would we need to cube in order to get 27x cubed, and what would we need to cube in order to get 64? And I'm hoping that you are saying 3x needs to be cubed in order to get 27x cubed, and 4 needs to be cubed in order to get 64. So with that in mind, this here is our u, and this is our v, and the formula that we are using is this one right here. Alright, so if we're going to use that formula, let's go back down and use that formula. So we are going to have u plus v is going to be 3x plus 4, and then we need u squared, which is 3x, careful here, 3x quantity squared, minus uv, it's going to be minus 3x times 4, plus v squared, which is plus 4 squared. And we can simplify this a little bit and get this to look like 3x plus 4 times 9x squared minus 12x plus 16. Alright, so that is the factored form for 27x cubed plus 64. We've written it in factored form. Alright, so that brings us to trinomial factoring. And really, I would say there are two methods. The first method is guess and check, which maybe you learned in Algebra 1. And the second method is the product sum technique, which your book calls factoring a trinomial by grouping. And so I personally prefer the product sum technique, but if you're good at guess and check, that's fine also. I am going to show you how to do the product sum technique in case you want to use that method for factoring. Alright, so let's take a look at this example. We're asked to factor 20x squared plus 2x minus 6. Well, first thing I would say is look for any common factors. Does anything go into all three of these terms? Looks to me like that's a yes, because we could factor out a 2. So we would have 10x squared plus x minus 3. And at this point, it's time to use our product sum technique, which actually I have typed up for you. So I'm going to ask the substitute to give those papers to you. And those are the half sheets of paper that have the product sum game on the first side and the product sum technique on the back. So let's follow along with that. Really, this is going to be your A. Let's see, let me identify this. A is going to be 10, B is 1, and C is -3. All right, and so what we want to do is we want the product, which is going to be the product of A and C. So that's going to be a -30. And we want our sum to be the B value, which in this case is 1. So here's the name of the game. You're looking for two numbers that multiply together to give you that product, but they add to give you that sum. So what two numbers multiply together to give you -30 and add up to 1? That would be 6 and -5. So those are the two numbers that you would want, right? And so what we're going to do is we are going to take out this middle term here. Okay, that's going to be taken out, and we're going to replace it with a 6x and a -5x, because those will add up to the 1x that we had here. So it's going to look like this: 10x squared plus 6x minus 5x minus 3. And at this point, we are going to factor by grouping. Don't worry, I have not forgotten. We still do have a 2 that's kind of along for the ride here in front of the whole thing. But let's factor by grouping like we did earlier in this lesson. What can we factor out of 10x squared plus 6x? We can factor out a 2x. What's going to be left is 5x plus 3. And what can we factor out of the -5x minus 3? I think just a -1. We do need to write -1, and then we'll have 5x plus 3. We have the same thing in parentheses here, and that's great. That's what we want. So we can factor that out in front. Let me do the different color here. So we are going to have 5x plus 3 times 2x minus 1. And don't forget we had this 2 along for the ride. So I'm just going to write that out in front. And then this is going to be our answer in factored form. All right. So that really is factoring a trinomial using the product sum technique. And so here are our guidelines for factoring polynomials. All right. The first guideline is to always look for common factors. Okay, like we did here, we saw that there was a 2 that we could factor out in front. All right, second step is check to see if any of our special polynomial forms work. Is there a difference of 2 perfect squares, difference of 2 cubes, etc.? Third step is check to see if it's factorable by grouping. If there are 4 terms, it may be factorable by grouping. And lastly, is it a trinomial? Then use guess and check or product sum. All right, and that's pretty much it for my notes on section 8.3. And I am hoping that now you will be able to complete the 8.3 gift with your classmates. All right, thank you for your attention, and I will see you next class.